Hi guys, welcome to my YouTube channel, The Industrial Guy. In today's video, I will discuss about the relay and contactor, the difference between relay and contactor, how to read contacts and coil information from physical relay and contactor. Now let's start. Relay. A relay is a simple electromechanical switch that connects or disconnects two circuits. But instead of manual operation, a relay uses an electrical signal to control a electromagnet, which in turn connect or disconnect another circuit. There are two types of relays. Number one, electromechanical relay. Number two, solid state relay. In today's video, I will just discuss electromechanical relay. In future video, I will discuss about solid state relay. Now, contactor. A contactor is an electromechanical control device that used to make and break the connection between the load and power supply. Now, the second part of our video, comparison between relay and contactor. There are several differences among relays and contactor. However, I will just discuss two differences in this video. Number one, load capacity. The first difference among a relay and contactor is that both have different load capacities. Relay are used with electrical load at a range of around 10 amperes or less, while contactor load capacity is greater than 10 amps. Number 2, open and close contact standards. The second difference is that relay are designed to operate in both ways, which stand for in normally open or normally closed as per function demand, while contactors are designed to operate in a normally open configuration. This can be summarized as when the contactor is triggered, there is no connection of contactor with circuit, while the relay can have or not. Now the third part of the video, that is physical representation. This is a relay in industries. How we identify a relay? You can see at the bottom of the diagram, of the bottom of the relay there is a diagram which shows the information about the contacts and coil information. Basically this is a 8-pin relay. You can see pin number 1, there basically we have two sets. These are auxiliary sets, number 1, number 2, and this is the coil. We have in one set, pin number 1 is our common point, pin number 4 is normally close point. Pin number 3 is a normally open contact of this set. Now let's talk about the second one. Here pin number 8 is the normally close. Number 8 is a common point, and pin number 5 is normally close point. You can see pin number 6 is a normally open contact of this set. Pin number 7 and pin number 2 are the coil terminals. Okay, we got the information about the pin configuration, but still the coil information is not clear, like is this a 24 volt coil, is this a 220 volt AC coil. For that information we have to check the top of the relay. Sometimes we have the information on the side, same in the diagram view, but here in this relay we don't have the information available. So we will check the top view. This is a top view of this relay. Here you can see this is a symbol for relay coil. You can see it's written that this relay is of 24 volt DC. Okay, you can see this is the pin number 1. This is the back view. Okay, pin number 1, pin number 2, so on. Now move to the second example. This is Omron 14 pin relay. Okay, we have to read the same. It's very easy. In industries we use this practice. Okay, pin number 9, we have 4 sets available in this relay: set 1, set 2, set 3 and set 4. This is the coil. These two are coil terminals. You can see pin number 9 is a common point. Pin number 1 is normally close contact. Pin number 5 is normally open contact. When the coil got energized, this contact will be shifted to this. This is the way how we read. Same logic will apply for all the 4 sets. Pin number 13 and pin number 14 are coil terminal. Okay, this is the top view of the relay. Here you can see the coil voltages are mentioned 24 volt DC. If it's not available in the top view, we can have this on the inside coil. You can see 24 volt DC written. Same, we have now the third example. This is the same relay with 240 volt coil AC. These two examples were DC 24 volt. Now we have the example of 220 volt DC, 220 volt AC. Here you can see it's written in the coil. This is also the 14 pin relay. Pin number 1, pin number 2, pin number 3, just like that. You can see pin number 9 is a common point. This also has 4 sets. Pin number 9 is a common point. Pin number 1 is normally close point, and pin number 5 is normally open point. Pin number 10 is the common point. Pin number 2 is the normally close point, and pin number 6 is normally open point. Same for these two also. Pin number 13 and pin number 14 are coil terminal. Okay, now let's move to the contactor. Here you can see this is a contactor. This is the contactor basically has AC coil. To energize a contactor we need AC only. Okay, pin number 1, pin number 3, pin number 5, or L1, L2, L3, pin number 2, pin number 4, pin number 6, T1, T2, T3. These are the main contacts of the contactor. And this is auxiliary 21, 22. This is normally closed auxiliary. Okay, here we connect the load. In these 3 terminals we connect 3-phase load, and these are the auxiliaries we use for indication purpose and other purpose. I will discuss in future videos. I will discuss the control diagram and all that in my future video. This is the model of this contactor, the model number LC1 90901, and this is the ratings nameplate. Okay, and the threshold current for this is 25 amps. If you are working in a single phase voltages 220 to 230 volt, the contactor will give the performance of 2.2 kilowatt. If we are working on a 3-phase system, the contactor will give us the performance of 4 kilowatt. If we are working in a voltages 660 volt, so the contactor will give us the capability of 5.5 kilowatt. This is Schneider Electric brand Telemechanic. Now move to the second example. In the second example you can see these are the I hope this image is clear. 1 2 3 here, 4 5 6. Okay, these are the main contact of this contactor, and these are the auxiliaries. You can see NO, NC, and these are the coil of this contactor. Okay, I just theoretically giving you the idea how it's working. Basically, when the coil energized of this contactor, pin number 1 got shorted to pin number 2, pin number 3 got shorted to pin number 4, and pin number 5 got shorted to pin number 6. When de-energized, again this will be open circuit. These are the rating of this example 2 contactor. These are mentioned. You can see here representation is also available. The threshold current is 25 amps, and if you can see here they have shown us how it's written. The numerator is of voltage and denominator is of kilowatt. If you are working on a 230 volt, it will be of 2.2 kilowatt. If the voltages are 400, it will be of 5.5 kilowatt, so on. Okay, now let's move to the third example. You can see the model of this contactor is this, and these are the main contacts of this contactor. Okay, auxiliaries relay coils are over here hidden, sorry, and these are auxiliary. 21 is above, and this is 13. The same here. 14 is above and 22 is down. So we identify the contact and auxiliary information. That's all for today's video. If you like my video, do subscribe my YouTube channel. Thank you.